What if I told you that the dollar in your pocket was once just plain paper? And before it ever reached your hand, it survived fire, pressure, ink, secrets, and strict tests most things would fail. In this video, you're about to see the hidden journey of a dollar bill, from raw material to powerful currency. Every stage, every transformation, and the reasons behind them. Once you see this, you'll never look at money the same way again. If you enjoy uncovering how the world really works, hit that subscribe button and turn on notifications, because I bring you more mind-blowing stories and processes like this. Let's begin.
The foundation of U.S. currency begins with selecting high-quality raw materials that ensure durability, security, and a distinctive feel. The paper, often called the substrate, is not ordinary paper but a specialized blend designed to withstand wear, resist counterfeiting, and incorporate embedded security features. Primary raw materials include cotton, 75%, and linen, 25%, sourced from rags, textile clippings, and remnants rather than virgin fibers to achieve the right texture and strength. These materials are inspected for purity to avoid contaminants. Additionally, small amounts of red and blue synthetic fibers are prepared separately for embedding. Paper-making chemicals such as sizing agents to control ink absorption, strength enhancers like resins, and colorants are mixed in precise ratios. No starch or clay is used as they would make the paper too brittle or absorbent. Water is a key component, purified to prevent impurities. 4 inks, prepared later, raw pigments, oils, dryers, and solvents are sourced, but we'll delve into that in a later step. This raw material phase emphasizes sustainability, with cotton often from recycled sources, and rigorous quality checks to meet federal standards. Once sourced, the cotton and linen rags are fed into massive pulping machines at Crane Currency. The process starts in a giant rotating sphere or hydropulper, where the rags are mixed with large volumes of water, typically in a 1:20 fiber-to-water ratio, and agitated vigorously, similar to a high-powered washing machine. This breaks down the materials into individual fibers, creating a uniform pulp slurry. Mechanical beaters or refiners then further process the slurry, fraying the fibers to increase surface area for better bonding. This refining can last hours with adjustments to pH levels, around 7 to 8, and temperature, up to 140 degrees Fahrenheit, to optimize fiber length and strength. The red and blue security fibers are added during this stage, distributed randomly throughout the slurry to deter counterfeiting, as drawing them on later would appear flat and detectable. Chemicals are incorporated here. Sizing agents to make the paper resistant to feathering ink, and strength agents to ensure it can endure folding up to 4,000 times without tearing. The slurry is continuously tested for consistency, viscosity, and fiber distribution using spectrometers and microscopes. This step is crucial for the paper's crisp, durable feel, which is refined until it matches the exact specifications. No wood pulp is used, avoiding the brittleness of standard paper. The refined slurry is pumped onto a four-drinier machine, a continuous wire mesh conveyor where water drains away, allowing fibers to mat together into a wet web. This web is pressed between rollers under high pressure, up to 50 tons, to remove excess water and compact the fibers, forming thin sheets about 0.004 inches thick. During formation, security features are integrated. Watermarks are created by dandy rolls or molds that vary paper density, causing subtle tonal differences visible in transmitted light, e.g., a portrait matching the printed one. Security threads, thin polyester strips with microprint text like USA 100, are woven in via specialized feeders, positioned differently by denomination, e.g., to the right of the portrait on $100 bills, and designed to glow under UV light. For higher denominations, additional elements like embedded holograms or color-shifting fibers may be added. The sheets are then dried in heated ovens at controlled temperatures, around 200 degrees Fahrenheit, to set the structure, followed by calendering, smoothing between steel rollers, for the signature crispness. Quality control involves scanning for uniform thickness, fiber distribution, and feature placement. Defective sections are discarded. The finished paper is wound into large rolls or cut into sheets, then shipped under armed guard to BEP facilities, as unauthorized possession is illegal. Upon arrival at BEP facilities in Washington, D.C. or Fort Worth, Texas, the focus shifts to ink formulation. Inks are custom blended in-house using raw pigments, e.g. iron oxide for black, copper phthalocyanine for green, vehicles, oils and resins for viscosity, dryers, cobalt or manganese compounds to speed curing, and solvents. Each type is tailored: black ink for faces, green for backs, metallic for icons, and color-shifting inks, using optically variable pigments that change from gold to green, for anti-counterfeit features on $10 plus notes. Blending occurs in high-shear mixers under controlled conditions to achieve exact color matches and drying times. Inks must adhere to intaglio plates without smudging and resist fading or chemical alteration. Quality testing involves spectrophotometry for color accuracy, rheometers for flow properties, and aging simulations. Security inks incorporate tagaunts, invisible markers detectable only by machines. Batches are produced in secure labs, with waste destroyed to prevent misuse, ensuring inks contribute to the multi-layered security. With materials ready, the artistic and technical phase begins. Designers at BEP create concepts using software and sketches, incorporating portraits, e.g. Franklin on $100, vignettes, and anti-counterfeit elements like microprinting. Engravers then translate these into steel dies using burins, scalpels, and digital tools. Each line, dot, and dash is hand-etched or laser-assisted for depth variation, creating intricate patterns that are nearly impossible to replicate. A single portrait might take weeks, with thousands of fine lines for shading. Dies are inspected under magnification, repaired, hardened via heat treatment, and chrome-plated for durability. Multiple copies, side-lay plates, are made via electroforming, where nickel is deposited onto the master to create working plates. This step merges artistry with engineering, ensuring every detail enhances security and aesthetics. The first printing stage uses offset lithography on massive sheet-fed presses, over 50 feet long, 70+ tons. Currency sheets are fed in, and background colors and subtle patterns are applied simultaneously to front and back using rubber blankets that transfer ink from plates. For $5 plus notes, this creates intricate, denomination-specific backgrounds and blended colors, e.g. peach and blue gradients, building security through unique fingerprints of ink overlap. Presses run at 10,000 sheets/hour, with operators checking every 500 sheets for registration, alignment within 0.001 inches, and color via densitometers. Computer vision systems monitor in real time. Sheets dry briefly before advancing, preventing smudges. Next, intaglio presses, 57 tons, 10,000 sheets/hour, apply raised elements. Engraved plates are inked, wiped clean, leaving ink in grooves, and pressed against sheets under 20 tons of pressure, creating tactile portraits, vignettes, numerals, and scrollwork. Backs print first in green, drying in vaults for 72 hours, vaults hold $50 to $100 million. Faces follow in black. 432 or 50 note sheets. This imparts the sandpaper feel, with inks penetrating the paper for permanence. Precise temperature, ink at 100 degrees Fahrenheit, and humidity control prevent defects. Printed sheets undergo rigorous inspection via the Offline Currency Inspection System, OCS, where cameras scan both sides at 2.5 sheets/second, analyzing 125,000 pixels per note, 4 million per sheet, for defects like smudges, misalignments, or ink inconsistencies. Software flags issues using AI algorithms trained on perfect samples. Good sheets advance, rejects go to single-note reclamation. This ensures 99.9% quality, with human overrides for edge cases. Surviving sheets move to letterpress, where rotary presses add final details. Green serial numbers, unique alphanumeric codes, black Federal Reserve seals, green Treasury seals, and district identifiers. 216 subject sheets are processed together, with inks applied via raised type for crisp embossing. Equipment like cope/pk integrates this with later steps for efficiency on certain denominations. Finally, sheets enter guillotine cutters in the cope/pk or LEPI systems. Horizontal cuts first, then vertical, yielding individual notes. Notes are banded in 100s, bundled into 1000s, shrink-wrapped into 4,000 note bricks, $400,000 for hundreds of dollars, and collated into 16,000 note cash packs. LEPI, 144 feet long, combines inspection, printing, and packaging $4.1/$5 notes. Final single note inspections reclaim goods from rejects, with all output barcode and vault stored for Federal Reserve distribution.